Hi, this is Mr. McGovern. This is the fifth video in the electric circuit series in level 2, and we're looking at IV diagrams. So IV diagrams are a sort of a made-up method to help solve circuit problems. The last two videos we looked at what voltage was and what current was, and we came up with these rules for series and parallel. So in a series circuit, the total voltage is split between the bulbs, but in a series circuit, the total voltage is the same at all points. In a parallel circuit, the total voltage is the same in each branch, and the opposite. In a parallel circuit, the total current is split between the paths. So if you can remember those and work with these, go ahead, you're going to do really well. The cool thing about these IV diagrams is they remember the rules for you. The rules are built into the way you draw these diagrams. And so a lot of students, I find, top students and students who struggle, find these diagrams really, really useful. So I implore you to use them as well. So let's go through the rules really quickly, and then we'll just go straight into some examples. So the first thing is make sure you redraw your circuit so the battery's at the top, how we have been drawing circuits in the video so far, and all the components are along the bottom. Then you draw your IV diagram and then you solve. So what does it look like? Okay, so here's a circuit, a parallel circuit. This one already has all the battery at the top and all the components are along the bottom. So for the IV diagram, the first thing we do is, let's say in this question we've been given a whole bunch of information and some information is missing as well. With our IV diagram we draw a box. And we label the height I and across the top V. That's where the IV comes from. I for current, V for voltage. Then what we do is we draw inside the box, we draw the shape of what our bulbs or components are. And so see in our circuit here we have, in parallel we have one bulb above another bulb in the diagram. So that's what we draw in the IV diagram. We draw one box another above another box, and that's A and B. So this IV diagram is for a parallel circuit. Then we put in the values that we know. Let's start with voltage. So the width of the boxes is voltage, and obviously the height's going to be current. The total voltage is the total width of the whole diagram. So that's 9 volts, easy peasy. Now if you look at A, you see that the box A has the same width as the total. So therefore, A has the same voltage. It has 9 volts. And then hopefully you notice that B also has that same width. It also is 9 volts. So now we've changed those down here. We know those values. Let's deal with current. So current's about the height. So I'll just get rid of the voltages just so we can concentrate on one at a time. What do I know? I know the total current. So that's the total height is 3 amps. And it doesn't mean that A and B are necessarily split that 3 amps in half. It could be that one takes more than the other. But I know, looking at this diagram, that the height of A plus the height of B equals the total. So what have I been given? I've been given the height of A is 2 amps. Therefore, I know the height of B must be 1, because 1 plus 2 equals 3. So now I've got all of my information. Now, all I've been doing is remembering what the rules are for current and voltage in a parallel circuit, but I don't really have to remember them because the diagram has remembered them for me. Let's do another one. So here I have a circuit, and the first thing you realize is that the battery is not on the top, it's along the side, and the components along the side. So I'm going to flip this around and make this series circuit look like that. I've got some information and I'm missing some information that I want to find out. So IV diagram, draw a box. Series circuit, you have 2 bulbs beside each other, so you have 2 boxes beside each other. They're not necessarily the same size. We don't know how wide they are. We're just going to put in the information we do know and help solve it. So I'm going to put my totals in. My total width or my total voltage is 12 volts. I don't know what my total current is. They haven't given me that. Let's deal with voltages first. I've also been given the voltage at B is 9. So therefore, if the width of B is 9, the width of A must be 3, because 3 plus 9 equals 12. So that's all sorted. Now let's do the currents. I know, I don't know the total current, but I do know the height of A is 1 and the height of B is 1. They are the same height. I don't need to add them together to find the total because the total height is just going to be 1 as well. And all solved. Again, this IV diagram remembers the rules for you. It's built into the system. Let's do a really complicated one. So there's 3 bulbs here and I've been given a bunch of information. What I'm going to do is I want to draw it so the battery's at the top and all the bulbs are along the bottom somehow. So this redrawn, this is equivalent. I have electricity comes out of the battery, goes all through A, and then it splits into B and C. This is equivalent because even though it goes around the corner, it all still goes through A and then goes through B and C. So I want all the components drawn along the bottom. Once I've got them drawn along the bottom, then I can draw my IV diagram. So in this case, draw the box, the same thing, and I want to split the box up into shapes so that there's one beside and two on top like that. One beside, two on top, B and C. Put in the information I know. Total voltage I know is the total width of the whole thing is 20, and I've been given C as a width of 8. Well, C and B have the same width, so that must be 8 as well. Cool, I got that information. And A must have a width of 12 for the total width to be 20, because 12 plus 8 equals 20. Great, I've got all the voltages. Now let's do the current. What do I know for current? I don't know the total, but I do know B and I do know C. So the heights of those individually is 1 and 0.5. That means the height of A, which looks like the total height, is going to be 1.5, and that's sorted. And now I can do the totals the same as A, 1.5. So this is a really complicated circuit, but again, the rules are written into the IV diagram. So here it is here. All of these rules that we talked about in series total voltage is split, but in series total current is the same, and parallel total voltage is the same, and parallel total current is split. All of those rules are remembered within the IV diagram. It honestly makes life a lot easier for you. So practice using it, and you'll see as I go through to solve some exam questions near the end of the series, I use it all the time as well.